And the same money tracing problem to 2 tools, dozens of hops, thousands of addresses to look up. One of them takes hours, sometimes days.
The other finishes before you've finished reading this sentence.
Same blockchain, same public data. So what's actually different?
The answer isn't a faster computer, it's a different engine.
Start with how blockchain data is actually stored. A blockchain was designed to be validated, not investigated. The core wallet software that every network runs on answers one question at a time. Ask it for a transaction, and it hands you that transaction. Ask it a real investigative question, every address this wallet ever touched, and out of the box, it can't answer at all. That relationship simply isn't stored. So to follow money, you make the request thousands of times. One address, one transaction, one round trip, then the next. Each call is quick, but a single trace is thousands of them, in sequence. That's where the hours go. To make wallets usable, the industry built indexers on top of the raw data. But look at what they were built to answer. What's my balance? What can I spend right now?
That's the unspent set, perfect for a wallet. It carries a lot of information a forensic investigation never needs, and almost none it does.
And it still answers one address at a time. Nobody built the base layer to walk a chain of custody across 40 hops. The same is true on Ethereum, on the EVM chains, on tokens. Different data, same shape. Built to validate and to spend, not to investigate. Where do the forensics platforms come from? They sit on top of exactly these mechanisms. They pull from the same node calls and the same indexers, then load it all into a graph and label it. And yes, they have APIs, polished ones. But an API is only ever as fast as what runs underneath it. The graph still has to be walked, hop by hop. And a graph gets slower as it grows, right when a big case needs it most. Faster front end, same engine underneath.
neuTracker doesn't ask the blockchain 1,000 questions. It reads the raw block data once, directly, and indexes it a new way, purpose-built for one thing, following the money. The relationship between every address and every transaction is worked out while we index, not re-derived on every question you ask.
So the question that used to be thousands of separate lookups
becomes a single query. Where did this go across every hop? One request, not 10,000. And because it's built on the structure of the data, not one chain's quirks, the same engine covers Bitcoin, Ethereum, and the EVM chains, and tokens.
Here's what you're looking at. This is a live neuTracker server. Every API, every alert, still processing in the background while this scan runs. We're onboarding the entire Bitcoin blockchain in 3 phases. Blocks, then transactions, then addresses. Each one scanned and cross-referenced as it goes.
Some footage is sped up. The run itself is real-time. Watch the clock.
Phase 1. Every block. All 955,000 of them. 42 seconds. Phase 2. Every transaction. 1.4 billion of them at 2.5 million per second. Every address and every public key ever revealed on the chain. 3.8 billion addresses, 2.8 billion keys, every one of them cross-referenced as it lands.
Step back and take in what just happened.
Every block, every transaction, every address, and every public key ever used at any point in Bitcoin's entire history. Scanned, indexed, cross-referenced, and made ready for forensic work in under 20 minutes. And here's what matters. That only happens once. One onboarding scan per chain. After that, the chain is monitored in real time. As each new block drops, it's scanned in seconds. every tracked object updated, every alert fired with accurate, verifiable, freshly cross-referenced forensic detail. The 20-minute number is a one-time cost. From then on, it's live.
So how does neuTracker move through that much data that fast?
That part's proprietary, but here's a hint. It's hyper-parallel, and it borrows from the same advanced techniques behind high-frequency trading and the worldwide transaction processing that MasterCard and Visa run on. Only here, those ideas are applied to the unique structure of a blockchain's distributed ledger. And that's just the start, the leading edge of years of performance work.
So what does that speed actually buy an investigator? Watch.
March 2026. BitcoinDepot, a publicly traded Bitcoin ATM operator, discloses a breach to the SEC. The filing gives a dollar figure and not one address. Within hours, the independent investigator ZachXBT reconstructs it from public chain data alone, 19 theft addresses. At the time, not one commercial compliance tool had flagged them. We take one of those addresses, add it to tracking, and run BackTrace, both directions.
Stopwatch to run. It's already done. Under a second. 6 transactions, 32 classified events, every one dated, labeled, and cross-referenced. March 20th, the money lands. neuTracker traces it straight back to BitcoinDepot's own settlement wallet, the source, paid out in 3 batches that morning. March 22nd, 11.5 Bitcoin consolidated in a single sweep and cashed out to a known exchange. That fires a critical alert on its own. Stolen funds converting to cash. No prior monitoring. Every hop a real transaction, read straight from the chain. Run it again, you get the same answer.
That against the public record. BitcoinDepot's SEC filing gave a dollar figure and not one address. ZachXBT recovered 19 addresses by hand and named the exchange. One cluster from a live investigation.
neuTracker started from a single address with no prior monitoring and resolved more. It named the source the public record left out, BitcoinDepot's own settlement wallet. And it separated those 19 into what they really are. 9 funded directly, court grade, 9 routed through a mixer, qualified, and 1 that never belonged to the case at all. Not one aggregate number, but a decomposed, reproducible loss. 46.8 Bitcoin, graded to what a court would accept.
Faster than commercial tools flagged it, and more precise than the public investigation. neuTracker isn't a faster block explorer. It isn't a graph bolted onto the same old lookups. It's a different engine, built for the question investigators actually ask.
A new generation of forensic tools for the blockchain.
neuTracker. See it at neuTracker.net.